Maybe it's good giving you some references right now. A really good book on color management is called Real World Color Management. Another good thing is anything ever written by Charles Point, and I hope I'm not butchering his last name. And then lastly, Avid High Resolution Editing Workflow Guide, which explains DS color management and use of LUTs and those things. So let's go back and see how and where Avid DS LUTs are deployed. They can be deployed at the capture or link stage. In capture settings, the input levels that's been there for ages is really nothing other than a LUT selection. This is where you tell Avid, I'm bringing in an image that's in sRGB color space, or it's linear, or it's ITU 601, 709, and so forth. If you don't do this selection right, the colors in the image are not going to look correct. How do you know if you're making a right selection? You really can't. You need to make a best guess. You can open an image in Photoshop maybe and look which profile it's tagged with. More often than not, I make a wild guess and interpret things as either sRGB or legacy graphics if they're coming from graphic designers, and then look at the colors in the scope and see if I made a right choice. Now, of course, this is all highly subjective. It's definitely not the best way to work, but a lot of times you'll ask someone, hey, what color space is your image in? And they don't even know what you're talking about. So captured settings is one thing. This determines any file-based things. If you're in 444 sequence in Capture Tool, there will be a LUT selection. So for example, this is something you would use if the color space on the tape is not ITU 709 on high def tape or 601 on a standard def tape. This doesn't happen too often, but it can with some cameras like Viper. If you can have a Viper recording on HD cam tape that actually has a different color space than Rec 709, so you can just tell DS what to expect. And then the special case of DPX and R3D imports, they have their own LUT settings. All of this that I'm explaining really applies mostly to 444 sequences. All of this can be used in 422 as well, but it does get more complicated. And if you're doing any of this in 422, you probably already know what's going on and you don't need much of my help. DS color management works in a more straightforward manner in 444, let's just put it that way. So doing the edit or compositing stage, we can use LUTs applied as clip or track effects. We can use them inside of tree nodes, and we can also use them inside of a color corrector. And if you're just changing gamma in the color corrector, you really won't be able to go from one color space to another in a precise manner, but you can kind of get in the ballpark. And also color corrector, which we'll see later, does have its own LUT option. And then during the output stage, this third thing down here, at the output stage, the output tool has its own LUT selection. If we're outputting to files, this is a LUT selection we can make from pre-made choices. Anything not included in here, some sort of a special conversion that you need to do, would have to be done using a LUT effect or a 3D LUT applied as a track effect in DS timeline. And DPX output, if you select the DPX format, there will be an option over here where you can select from one of the pre-made options, also load one from a file. And there's one other special case of LUTs in DS, and that's a viewer LUT. This works only in 444. Viewer LUT doesn't really change any values. Nothing is hard burned into the image. It only affects the DS viewer, what you're seeing in the DS viewer on the computer monitor. And it's set to sRGB by default, as this is the color space of most computer monitors, but this can be modified to suit your needs. Viewer LUTs are accessed by right-clicking on the viewer, going to Viewer Properties, going to Display tab, and either disabling a viewer LUT. Notice how the image went noticeably darker. That's because we're no longer applying a sRGB LUT to it. We're just looking at linear color, which will appear a lot darker. So for example, let's look at one of our image examples. This one, as soon as I enable the viewer LUT, it looks normal again. If we look at it as a linear image, it looks perceptually a lot darker. And of course, we can select any other LUT over here if this is what our display device supports. 601, 709 will be somewhat similar to sRGB, for example. So that's 601, 709, and this is sRGB, which is the default setting. There's a slight difference. And to complicate things even further, but it's really not complicated, it just gives you a lot more flexibility. DS also ships with several external monitoring LUTs right here in this directory. These can be used with some external LUT boxes like Blackmagic's HD Link. So for example, we're looking at a print density log 985 to Rec 709 LUT right here. This LUT would take sort of a flat looking film scanner color and display it properly on a Rec 709 device like most video monitors. One thing to remember is these external monitoring LUTs are not something that you have to use. They're just for your convenience. If you do have an external device And if your color pipeline is set up in such a way that you can utilize this box and it makes more sense to do it, then you can use these external monitoring LUTs. Alright, so let's finally start applying some LUTs in DS and playing with that. Here's a photograph that we could say it's well balanced, perceptually looks okay. That's our starting point. If you go to video effects and go to linear to log, this is a LUT that's been around in DS for quite some time, which has been supplanted by a better tool right now, but I'll show you this one as well. This one takes linear input and converts it to log color. See the shape of the curve. This is somewhat similar to what you saw when I was typing up those transfer functions in Wolfram Alpha website. Like what we did on the website, what we can do is we can apply the inverse of this LUT on top of this, and that will restore the image back to where it was. So watch this. We'll go back up here, go to log to lin, and here it is. If we select both of these and disable them, enable or disable, see there's no difference because we have a LUT and an inverse LUT. Why am I showing you this? Well, let's pretend that this is the image that you received from a film scanner or some sort of digital camera that has its own color space. If you have the LUT for that particular source, you can just simply apply it and the image will look right. So this one is, let's pretend it came off a scanner. You could, using this old effect, just apply log to linear, and here's your color. Somewhat similar to this is use of LUTs in the color corrector. If you're going to color correct anyway, and using a LUT within the color corrector doesn't clash with your overall color pipeline, you can simply use the levels, red, green, and blue tabs to load up your LUT. Here I'm kind of doing the opposite from what I showed you. I'm taking a linear image and making it into a log, so I'm messing it up. But let's do this right. So go back up, and I'm going to copy and paste this color corrector on top. So now we have two log transforms on top of one another. It's getting almost invisible to see. Our assumption is that we're starting with a flat looking log gamma space image, and when I enable this color corrector, I'm going to switch RGB tabs under the levels tab to go from log to lin. Unfortunately, you have to do one at a time, but that's okay because you won't be doing this on every single clip. So now, using the DS color corrector, we have perceptually balanced out this image, and we can start color correcting it. There's a lot more to this, so I'm not saying this is the only or the best way. There's actually a lot more to this, but at least it kind of gets you started, puts you somewhere. So now you can use any other controls in the color corrector to work on this image. The advantage of doing this in the color corrector is you're using only one tool instead of using a LUT and then color corrector on top. So everything's more economical, processing is faster, and all that kind of stuff. It's actually, in most cases, it's real time. We also have this new effect called LUTs effect, which is already applied to this clip over here. And look at the difference between these two. There is none. This one is using the older lin to log. This one is using LUTs effect, and they're doing exactly the same thing. But this is a new effect. It's capable of more stuff than the old one. It's typically the one I use, whether it's on the timeline or in trees as a node. The first tab, lin to log, and the third tab, log to lin, are really what the old effect does. So if I turn this off, the image snaps back to its normal color. This one's going to make it a lot darker. So, if this is the original image that we received from someone, we can go apply video effects, LUTs effect, log to lin, and it's getting darker, but you see it doesn't look right. And the reason why it doesn't look right, if you compare it with this one, is that we're using a wrong LUT. Now, this effect is different from the old one, that it comes with all these different options, and you can also load a LUT from file down here below if such file was supplied to you, or you build it yourself. What we need over here to make this look right is printing density. How do I know it's printing density? Well, simply because that's what I'm doing down here. So I'm just creating a inverse LUT, and its inverse is log to lin in printing density. So as you see, it's not only important to twist the gamma one way or another to make this belly flop or expand. It's also important to load the right settings, otherwise the color is not going to look correct. This effect comes with a 3D LUT option. Those have to be imported as files. No 3D LUTs are delivered with DS. They're really something you would use to transfer color with great degree of accuracy. You can also use LUTs as a track effect, whether on the individual effects track for video layers or on the top effects track. For example, I'll cut out with Control X this LUT here and apply it to the top effects track, and you can see how it's helping out with these two clips. If I turn it off, we'll have flat log color. If I turn it on, the color is going to look right. And then any work you do in between these two, any effects you stack up will be applied to the values prior to this LUT conversion up here. I'm not going to show you how this works in the trees, but it's very similar. You can apply all these LUTs effects as nodes in a tree. It's a lot to learn, and I really think that Avid High Resolution Editing Workflow Guide will give you some better ideas how to best deploy LUTs, because you need to know how DS underlining color management works. It's very flexible what you can do in DS as far as color management. But at least if you take away from this tutorial this simple thing, there will be something like if you get an image that doesn't look right, you can ask whoever supplied the image, well, what color space this thing is in, and then hopefully they'll be correct and you can fix that. So for example, see how this snow is all blown out? Well, we happen to know that it's encoded in red log, so we can go to Video Effects, LUTs Effect, go log to linear, enable red log, and there it is. It looks correct. Thank you for watching another perfectly boring tutorial on LUTs, and I have nothing for you to download this time. Just go ahead and play with LUTs a little bit.